Good morning, good afternoon, wherever you may be in your day. Thank you for choosing to make chemistry part of your day. We have a one objective slide. If you are given mass percentages, can you calculate an empirical formula? Remember, empirical formula is the lowest ratio of atoms of the individual elements within a substance or compound. Here's the process. I invite you to pause this and take a look at it. I'm certainly not going to read it to you, but I do want to point out the fourth step, which says convert from decimals to fractions. This throws people. So if you see something that's 0.2, I hope in your mind you realize, well, that's 2 over 10 or 1 over 5. That's a fifth. So this is what I mean. So if your number ends in 0.2, I want you to make it a fifth. 0.25, a quarter. 0.33, a third. 0.4, 2/5. You get it around the board. These are the only fractions I'll use in our class. We won't get into exotic things like 7/9 or anything like that. They do exist, but not as far as this class goes. And remember, all numbers have a little bit of error wiggle room. So if you see something like 1.19, that's not 1. That's wrong to call it 1. It'd be equally as wrong to call it 2. Actually, it'd be more wrong to call it 2, but you get the idea. If it was 1.8, it'd be equally wrong to call it 2. So what is it? Well, 0.19 is not 0.2, but you consider a little bit of wiggle room, and I would call that 1 1/5. 2.34. Again, not exactly 2 1/3, but awfully close, so we might round that to 2 1/3. If you have 2.03, it's not 2.1, it's not a tenth. Our ratios don't get that exotic with the size molecules we deal with in Chem 101, so you can just assume that's a little bit of error in your number, and that's really 2. So that's what I mean by that. All right. Let's go ahead and do a problem. And these are usually pretty straightforward questions. This is actually a tricky one as far as these things go, but it's not too bad. A compound is found to consist of carbon, oxygen, and hydrogen. Chemical analysis finds it to be 43.8% oxygen and 6.90% hydrogen. Determine the empirical formula. So this is real data you could collect in a lab, or you could send something off for analysis and that would give you back the elemental analysis or the percent of each element. Depending on what you pay for and depending on the testing, you get different elements. So this is pretty realistic. All right, so step number 1 is assume 100 grams. What that does for us is everywhere where you see a percent, it becomes grams. So 100% becomes 100 grams, so that's awesome. That makes the math quite easy. So that step was easy. Step number 2 is convert to moles. Grams to moles, moles to grams. That's formula weight. I know that one. We've been using that one. So I just put my gram of oxygen here, gram of hydrogen, and as you know I like to put the units in before I do the math. And this is just 16, 1.01, and 1. And sometimes people want to do things like O2 for oxygen gas. This is the element itself. So it's just a single oxygen, so it's just 16. And then carbon is going to be 12. And again, we just get these straight off the periodic table. Nothing you need to memorize. Just take the bigger number for each of the elemental symbols. I do need to know oxygen's O and carbon's C and hydrogen's H. And my question is, how did I know it was 49.3% carbon? And if you're thinking, well, the total percentage is always 100, so if I just take 100 and I subtract 43.8 and I subtract 6.9 and I get 49.3, you are absolutely correct. So do remember, percentages are always 100. So if they give you 2, you can calculate the third. And then from here, it's mostly hitting buttons on a calculator. And these are very formulaic, so people usually do quite well on this question on the test. And I will say there's 2 common mistakes people make. Mistake number 1 is to look at these numbers and round them off. Someone inevitably on the test will call this 3 to 7 to 4. Totally wrong. So what we need to do is clean up the ratio. The smallest number of atoms we could have is 1. So we want to make the smallest number equal to 1. Mathematically, you divide anything by itself and it equals 1. So the smallest number up here is 2.74. So we're going to divide all 3 numbers by 2.74. Technically, this would be moles, and that would cancel out. So we get 1 oxygen atom, 2.49 hydrogen atoms, and 1.50 carbon atoms. And this is the other place people make a mistake. You have to realize that 0.49 is essentially a half. This is 2.5. 1.5 is 1.5. And then the last mistake people will make is this is a locked-in ratio. So if we need to multiply this number by 2 to get rid of the half, we need to multiply everything by 2. So 2 times 1 gives me 2 oxygens. 2 times 2.5 gives me 5 hydrogens. And 2 times 1.5 gives me 3 carbons. And then lastly, we want to write this as a chemical formula. We won't write, something that looked like this. We want to write C3H5O2. There is a typical way that we write the elements in chemistry. We haven't done enough chemistry for you to know what that is yet. So really, if you put this in any order, I am super happy. You want to go carbon, hydrogen, oxygen, oxygen, hydrogen, carbon, oxygen. It doesn't matter. As long as you have 3 of the carbons, 5 of the hydrogens, 2 of the oxygens, you are A-OK, and you have solved this problem. So I hope this is pretty straightforward. It's really formulaic. Let me put a little twist on it, and then we'll be done. So sometimes we can do more than just the empirical formula, which is the lowest ratio. Sometimes we can actually get the molecular formula. What's the molecule look like? That would be even better information if we could get that. So if we run another experiment, such as run it through a mass spectrometer, it might tell us the total mass is 146. It'll be a pK 146. That's great. So if we have the total mass and we know the empirical formula, we should be able to figure out what that molecular formula is. To do this, you want to find the formula weight of the empirical formula. So that's step number 1. So we have 3 times 12 plus 5 times 1 plus 16 times 2. And I see that my piece weighs 73 grams per mole. And the question is, now remember, it's got to be a multiple of this. How many of my empirical formulas do I need to get to 146? And it's possible you're already there. A lot of times you'll do this and the lowest ratio is the molecule. That's totally fine. The molecular formula and empirical formula can be the same. They can be different like this though. So my question is, how many 73s do I need to get to 146? Hopefully if you're good at math, you've already answered this and you're like, Dr. Virgo, it's 2, 2, 2. Peace and love to you all. Or you can mathematically take the same idea of n, divide both sides by 73, or take the bigger formula weight, stick it on top of the smaller one, then you don't even have to think. That's not great. We want to think a little bit. And we get 2. Multiply through by 2, and I get C6H10O4, and we are done. Well done, folks. Notice not the smallest ratio, not an empirical formula, but it is a molecular formula. And I'm going to go have a drink of water and see if I can work on my speaking skills. Thank you so much for your time and attention, and I hope you are moving ahead with your chemical knowledge.